Hi everyone, what's up? Welcome back to my tutorial channel. It's Dania here, and today I'm going to talk about the risk analysis. For the risk analysis, I'm going to make two separate videos because this lesson is quite long and there's a lot of problems. So in the first video, I'm going to go over some overviews of calculation, scenarios analysis, sensitivity analysis, and break-even analysis. And in the next video, I'm going to talk about the Monte Carlo simulation and the decision tree. So first, scenario and sensitivity analysis. The rule of capital projection is we have to choose the highest NPV. And in order to compute the NPV, we need two things. The first one is future cash flows, and the second one is the project's cost of capital. Remember, I make a video of the cost of capital, so this is the lesson that continue to that lesson. There can be many possible scenarios in the future, and the NPV of a project is heavily dependent on which scenario. The base scenario is the one that serves as the average scenario based on management assumption. The NPV of the project is computed based on the set of assumptions. So let's talk about the risk analysis. Here, given a detailed profit projection of the project is provided below. The revenue, here we have two time frames, right? Time 0 and at the end of 5 years. So we consider this project over 5 years, okay? And we consider a couple of parameters here: the revenue, the variable cost, the fixed cost, the depreciation, pre-tax profit, the tax, the net profits, the cash flows, and the initial investment. However, here only the actually I'm going to show you how these numbers come from, okay? So here the pre-tax profits is the revenue subtract the variable cost, subtract the fixed cost, and subtract the depreciation. And we got 40,500. Look at here. 40,500 is the revenue, variable cost is 13,500. Fixed cost is 5,000, depreciation is 1,000. So now we use these four numbers to calculate the pre-tax profits, the tax, the net profits, and the cash flows. So here, the pre-tax profits, we take the revenue, subtract the variable cost, subtract fixed cost, and subtract depreciation. Here, depreciation is just the non-cash expenses. That is what you spend, but not using cash. And it is $21,000. The corporate tax due to this project is the pre-tax profits times with the tax rate. Here I assume that the tax rate is 34%. Of course, in some projects we might have different tax rates. However, for this project, I used 0.34, which is 34%. So we take the pre-tax profits times with the tax rate to find the corporate tax due. So we got the tax is 7,140. So the net profit is the pre-tax subtract the tax, which is 13,860. The cash flow is the net profits plus the depreciation, and we got 13,860 plus 1,000, which is equal to 14,860. And the NPV is the cash flow times 1 subtract 1 over P to the fifth, the whole thing over P, subtract initial investment. Here, P is the cost of capital. Remember in the video of cost of capital, I show you how to compute the cost of capital when both when tax is involved and when tax is not involved. So here we assume that the cost of capital is 0.2, okay? So we got the NPV here is negative 14,000 for 40.5. So this is how we calculate the risk analysis. And usually for like a project, we have to pick the highest NPV. So the main thing in order to compare between the projects, we have to compute NPV. See that? Now, of course, different projects will have different parameters, different factors, and it leading to we have different NPV. So we will have to consider the sensitivity analysis. That means we have to consider how sensitive it is of a project when one or some key factor change in values. So here the sensitivity analysis is basically a conduct of study that breaks the NPV assumption into its component assumption, show how NPV varies as these assumptions change, and we have to recalculate the NPV under the worst and the best cases of assumption for its parameters. And then from that study, we review which assumptions are the most critical. So we have 4 steps here. First, we have to break the NPV assumption into its component assumption. For example, we have a couple assumptions: the market size, the market share, the cost per unit, blah, blah, blah. And then we have to show how each of these assumption chains would affect the NPV values. That means we have to do one by one. Like we have to start with one parameter, change the value from the best to the worst or to the worst to the best, and we compare the NPV to see how sensitive it is. Would it be a big change or would it be a small deviation? So that is how we have to conduct in a sensitivity analysis. And after we make up the assumption from the best and the worst cases for each of these assumptions, we have to recalculate the NPV under these assumptions. And then under these assumptions, with different calculation, we will have to compare to see which assumption are the most critical. So before I go deeply into this study, I want to make an overview of how do you actually calculate NPV, so that when we change some factor, we can just follow the steps and calculate the NPV and compare. So here the NPV calculation is, first you have to compute the enrollment per year, and this is just the product between market size and market share. The revenue is the product between enrollment per year and the price per unit. The variable cost is the variable cost per unit times the enrollment per year. The protect profit is the revenue subtract variable cost, subtract fixed cost, and subtract depreciation. Remember, depreciation here is the non-cash expenses. The net profit is the pretax profits times 1 subtract 0.35. The reason for this is assuming the tax rate is 34%. So pretax profits times 0.34 is the tax. So we take the pretax profit, subtract tax to get the net profit, right? So it should be pretax profits times 1 subtract 0.34. The cash flow is net profit plus depreciation. That means the non-cash expenses. And the NPV is, remember here we consider 5 years, okay? We consider 5 years. If we consider with longer terms, let's say 10 years, 20 years, we have to change the power of P right here, the exponent of P. So here, assuming that P is the cost of capital and assuming that we are consider 5 years term. So the NPV is minus initial investment plus cash flow times 1 subtract 1 over P to the 5th, the whole thing over P. We're using P here as the cost of capital. And how to compute the cost of capital, just rewatch the video of cost of capital that I posted a couple of weeks ago. Alright, so now we are going to conduct a sensitivity analysis. I have given you the ideas of how the sensitivity analysis works and how we compute the NPV. So now we are going to apply it. So in order to conduct a sensitivity analysis, we basically vary the parameters one by one to the worst and the best cases scenario, keeping the other parameters fixed at their initial assumption. Alright, so let's consider the attack learning example. Here, the initial assumption is we assume that the market size is 300. The market share is 0.3. Price per unit is 415. Variable cost per unit is 150. Fixed cost is 5,000. Initial investment is 30,000. It's like before you invest, you have to make a plan. Okay, you have to make a plan. You have to estimate how much is the market size that you expect it to be. What's the market share? What's the price per unit that could be? What's the variable cost per unit? What's the fixed cost? Initial investment. These things are the setup assumption that we start at the beginning, right? Then now we have to consider when these numbers change from the worst to the best, because reality and expectation are huge different, right? So suppose that the worst case of the market size is 100. Suppose the market size is just 100 instead of 300. That is the worst case. The best case is 400. So for this assumption, we assume that the market size vary between 100 to 400. The second assumption, we assume that the market share varies between 0.15 to 0.4. The price per unit is the next assumption. We assume is vary between 350 to 500, depending on the situation, circumstance. The variable cost per unit also varies between 180 to 140. Usually why the worst case here is higher than the best case, because we expect less deviation. We expect less variance, right? For any project, we expect less variance, less deviation. So the variable cost per unit here, the worst should be high variable and the best should be low variable, right? It's kind of opposite to the other three assumption. Next, the fixed cost. The fixed cost here, the initial assumption is 5,000. However, we assume that this cost would vary between 6,500 to 4,00 and of course, like we expect to spend those costs, right? So the best case we have to spend only 4,000, and the worst case we have to spend up to 6,500. And the initial investment, the worst case we have to spend a lot of money on this project, and the best case we have to spend just 25,000. See that? So this is the assumption. Now, in order to conduct the sensitivity analysis, we have to start with the easiest case. That is when we have to, consider when only one parameter varies and we have to keep the other parameter fixed. So now let's start with market size. What we are going to do is we are going to vary the value of the market size from 100 to 400. Why? Keeping the market share, price under units, variable cost per unit, fixed cost, initial investment, they are under initial assumption. That means we keep market share 0.3, price per unit 450, variable cost per unit 150, fixed cost 5,000, initial investment 30,000. But for market size, we consider when it's from 100 to 400, and we see how the deviation would be. Alright, so now let's conduct a sensitivity analysis. And we are going to begin with the market size parameter by varying the market size from the worst of 100 to the best of 400 while keeping other factors first. Here we have two cases, the worst case and the best case, right? The worst case, just follow the NPV calculation. Enrollment per year is market size times market share. So we got 100 times 0.3 and it is 30. The revenue is the enrollment per year times the price per unit. We got 30 times 500, which is 13,500. The variable cost here is the variable cost per unit times with the enrollment per year, and we got 4,500. The pre-tax here is we take the revenue, subtract the variable cost, subtract here the 5,000 here is the fixed cost, subtract the fixed cost and subtract the depreciation. So we got 3,000 for the pre-tax. Now the net profits, we take the pre-tax times 0.66. Here 0.66 comes from 1 subtract 0.34 because the tax rate due is 0.34, and we got net profit is 1980. The cash flows, we have to add depreciation, so we got 2980. And the NPV here is negative 21,088 because 0.2 is the cost of capital, and we consider 5 years time frame. Now for the best case, we replace 100 by 400 and repeat the calculation, and we figure out that the NPV for the best case is 32,204.73. So there's a huge difference, right? The worst case is negative 21,088. The best case is positive 32,204, which makes a huge difference, like around 50,000 different, right? Now now we are going to change the other 5 parameters one by one, and after we repeat all the calculation, here is the table of result. For the market size, we have figured out the worst case is negative 21,088. The best case is 32,204. Now for the market size, market share, when we keep other factor fixed and the market share varies, then the worst case is negative 12,205.9, and the best case is 32,204.73. The next one, for price per unit, we also keep other factor first and consider worst case and the best case. So the price per unit here go from make the NPV goes from negative 3323.74 to 23,322.61, and so on. So this is the table of result, and now we consider the deviation. Basically, we take the best case, subtract the worst case. So if you do so, you see that the market size have the rated deviation, right? Because it varies between negative 21,000 up to 32,000. So they have a huge gap, right? It's a huge gap. So we see that market size is the most sensitive, right? NPV is most sensitive to the market size, or the market size is the most critical parameter. So remember the purpose of sensitivity analysis is first we break the assumption into its component assumption, and then we make an assumption under these assumption, and we recalculate NPV under the worst case and the best case for each of these assumptions, and then figure out and review which assumption is the most critical, right? Now so in the sensitivity analysis, we consider when only one parameter change, right? When only one of the assumption changes. Now for the scenarios, we consider something more realistic. In reality, certain parameters may move together, not independently, but move together. Like one factor change, the other factor also be a factors. They might move together, or they both change at the same times. So here for the scenario analysis, we have to consider NPV when couple parameters move together, change together. And here we consider the last example for market size, market share, and price per unit all vary, and the other 3 are fixed. And we just repeat all the calculation. You see that? Here we assume that both market size, market share, and price per unit was at the worst case. So we take the worst case for the market size, market share, and price per unit and put them all in here. And we got the number of enrollment. The number of enrollment, we take the market share, size and market share. Remember the market size at the worst is 100. The market share at the worst is 0.15. So we got 15. The revenue is the number of enrollment times with the price per unit. Here the number of enrollment at worst is 15, and the price per unit at the worst case is 350. So we got 5250. Then the variable cost is 150 times 15. Then we have the pre-tax profits, the tax, the net profits, the cash flow, and finally the NPV. So just follow the calculation. Here we consider the market size, market share, and the price per unit at the worst case. Three of them are the worst case, and the other one at the initial assumption. So a scenario analysis considers the effects of changing multiple parameters simultaneously. Now we consider the last analysis for today is the break-even analysis. The break-even level of parameters is the value of the parameter that makes the NPV 0 and PV 0, assuming all other parameters follow the initial assumption. The IRR of the project is the break-even level of cost of capital if it is treated as parameter. For example, now we go back to the assumption of attack learning example, and for example, we already have the cash flow is 14,860, and now we wonder what is the initial cost that make NPV is 0. That means we have to calculate the break-even level of the initial cost. So we got NPV is minus initial cost plus cash flow times 1 subtract 1 over 1.2 to the fifth, the whole thing over 0.2, and set is equal to 0. We solve for initial cost, and we figure the initial cost required should be 44,444 times 0.5. So that's how we calculate the break-even analysis. Here I just give you one simple example. However, in practice, we might have different parameters to be considered in break-even level. For example, I might ask you, we might be asked to find a break-even level for the market size, the market share, or the price per unit, any of the above assumptions. All right, so this lesson is quite new. We learning new concepts. So the targets of learning this lesson is understanding the methods of conducting risk analysis. Basically, we have to pick the highest NPV, and therefore we have to figure out how to compute the NPV in order to compare. And once we know how to compute the NPV, we have to understand the scenarios analysis and the sensitivity analysis. The sensitivity analysis consider when only one factors varies. The scenarios analysis consider when more than one, some of them move together. And for sensitivity analysis, we have to review which assumption is the most critical, right? And finally, we have to understand the break-even analysis. That is, at which level of assumption the NPV would be at 0. Alright, so that is it for today. Today there's no assignment because I have to finish one more video. I try to combine them all in one video, but then they become too long. So I break them into 2 videos. In the next video, I'm going to talk about Monte Carlo's assumption, simulation, and let me see. I'm going to talk about Monte Carlo simulation, the decision tree to model future outcomes, and analyze real option embedded in a project. So bear with me, wait for me for the next video. So that's it for today. Thanks so much for watching. See you next time. Bye bye.